Last time we read a complete discount function and answered why it compiles to WebAssembly instead of running as a script. Today we build one. Not a simplified toy version, the real scaffold Shopify's own CLI generates, the real configuration that wires it to checkout, and the real Rust logic that decides what discount a customer sees. By the end, you'll have watched every step of turning one CLI command into a live, working discount, using nothing but Shopify's own official tutorial source. Welcome back to Shopify Development Deep Dive. Part 9 showed you a finished discount function and explained the WebAssembly runtime underneath it. Today's episode is the build itself. We start from a single terminal command, walk through the Real-generated configuration, read the real Rust source for two separate discount targets, and finish by wiring the whole thing to an actual discount record using a real GraphQL mutation. Every file in this episode comes from Shopify's own current developer tutorial, still live on shopify.dev today. Here's what you'll see built, end to end. A discount function, scaffolded by the real Shopify CLI generate command, not typed from scratch. A single configuration file wiring two separate targets into one Rust project. The real cart line and order subtotal discount logic, read straight from Shopify's tutorial source. Separate, real free shipping logic, because shipping discounts are a genuinely different target with their own input and their own output type. And finally, a live discount record in a real store, created with a GraphQL mutation and pointed at your function using its stable handle. 5 stages, start to finish. First, scaffolding one CLI command generates the entire starter project. Second, configuration the extension's TOML file wires together which targets it handles, which input query feeds each one, and the exact command that compiles it. Third, each target's own graphical input query runs, fetching precisely the cart or delivery data that target declared it needs. Fourth, the Rust logic itself runs, reading that typed input and deciding what, if anything, to discount. And fifth, none of it does anything until a real discount record exists in the store and is pointed at your function by its stable handle. That's the step that actually turns code into something a customer can see at checkout. A short list before we start. You'll need a Shopify Partners account and a development store to actually test against. This is free to set up. You'll need Node.js version 22 or higher installed, plus Rust itself, plus the WASM32 unknown compilation target so Rust knows how to produce WebAssembly. Your app will need the right discounts and read products access scopes. And while part 9 of this series gives useful background on why functions exist at all, it isn't required every concept that matters gets reintroduced as we hit it today. This is the real command, run from inside your app's own directory. Shopify app, generate extension, with a template flag set to discount and a name flag naming this particular extension discount function RS. The CLI then asks which language to generate for this episode, and for the rest of today's build, we choose Rust. That single command produces an entire starter project, configuration, input query stubs, and Rust source files already wired together, ready to be read and understood rather than written from a blank file. This is the real generated configuration, current API version 2026-01. Notice it declares two separate targeting blocks, not one. Cart.lines.discounts.generate.run handles cart line and order subtotal discounts. Cart.deliveryoptions.discounts.generate.run is a completely different target, for shipping rates, with its own input query file. One Rust project, one compiled WebAssembly binary, but two independent entry points that Shopify calls separately depending on what kind of discount it needs calculated. The build command underneath compiles both into that one binary using the WASM32 WASIP1 target. This is the real input query for the first target. It's declaring, in plain graphical, exactly what the Rust code is allowed to see, every cart line's identifier and subtotal amount, plus which discount classes this particular discount was configured with. Nothing about the customer, nothing about payment details, nothing outside this scope at all. Shopify runs this query before your function ever executes, and the result becomes the typed input parameter your Rust code receives, which is exactly why the function's logic can trust its own input shape completely. This is the real top of the file, the part before the logic itself. 3 use statements pull in the generated schema module and the Shopify function creates prelude and result type. Then the Shopify function attribute macro sits directly above the function, and that one line is the entire bridge between ordinary Rust and Shopify's runtime. It's what generates the code that decodes typed input coming in and encodes a typed result going back out. The function's name matches the export this target declared back in step 2, and its signature is exactly the input type that graphical query produced, returning exactly the result type checkout expects. This is the real logic for the second target, the one that handles shipping. It's a genuinely different function, with its own input type and its own result type, because delivery discounts and cartline discounts are shaped differently in Shopify's schema. It checks whether the shipping discount class applies, and if it doesn't, returns immediately a valid, empty result, not an error. If it does apply, it reaches into the cart's delivery groups and takes the first one, the same defensive pattern the cartline function used for its cartlines, find the real target, or return a clear error rather than panicking. Before any discount can go live, this real block has to exist in your app's own top-level TOML file, not the extensions. The scopes line adds write discounts, the specific access scope required to create and update discount records at all. The function configuration metafield block underneath it is how a function's settings, percentages, messages, whatever your UI lets a merchant configure actually get stored and handed back to your Rust code as configuration data on every run. This is the real mutation that turns compiled code into something a shopper actually sees. Discount automatic app create takes a function handle, the same stable handle declared back in step 2, and a list of discount classes this discount should apply to. As of API version 2025-10, that function handle is all you need. Earlier versions required querying for a numeric function ID first. Run this once, successfully, and the store now has one live automatic discount pointed straight at the Rust code we just walked through. 2 real commands to close the loop. Shopify app deploy creates and releases an app version, a full snapshot of your app's configuration and every extension in it, including the function we just built. And for debugging, Shopify app function replay is the real Shopify CLI command that lets you pull a past execution and rerun it entirely locally, against the exact input Shopify captured, without triggering a fresh checkout just to see what your own code did. A few things to watch for. 2 targets means 2 schemas don't assume the cartline function's input and the delivery function's input share any shape at all, because they don't. An unmatched discount class must return an empty, valid result, exactly the pattern step 5's early return demonstrated, never an error and never a panic. Always test with app function replay before deploying any logic change to a live checkout, since a broken function fails silently from a shopper's point of view. And if you're wiring up that mutation from step 7, remember function handle only works this simply on API version 2025-10 or later. Older versions need a separate function ID lookup first. Pulling it together. 1 real CLI command scaffolds a complete discount function project written in Rust. 1 configuration file wires 2 genuinely independent targets, cart lines and delivery options into a single compiled build. Each of those targets carries its own graphical input query and its own typed Rust entry point, because the data each one needs is shaped differently. The right discount scope and a real discount automatic app create mutation are what actually turn compiled WebAssembly into something a shopper sees at checkout. And once it's live, Shopify app deploy ships new versions, while Shopify app function replay lets you debug any past execution entirely locally. That's a complete discount function, built from 1 terminal command through to a live discount a real customer would see scaffold, configured, coded, and deployed, using nothing but Shopify's own current tutorial source. Part 11 goes further into the shipping side of functions, building a custom shipping rate function in its own right. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in Part 11.